Hello there. So today we continue in our series where we have been examining questions that are called work and time problems. Work and time problems are numerical reasoning questions that we encounter in daily life, and apart from that, for exam purpose, uh, some of the exams that you could encounter such a question is interview exams, job preparation exams, scholarships, and all of that. So we started earlier by discussing type 1 questions. If you missed that, you can check the previous video in this series. I don't want to go back. That's we examine a question of Mr. A can finish your work in so days. Mr. B can finish in Y number of days, and what if they work together, how soon are they going to complete it. In this video we shall be looking at completion or progress, or whatever name we call it. Some of the question can twist to mean percent completion, some will say fractional completion, or they want to say, okay, if the question comes in this form, uh Tony can finish a work in 10 days. Melissa can complete the same work in 15 days. Now, if they work together, what will be the percentage completion? I mean, or what will be their progress after, say, 10 days, or say after 2 days? If you check them, what do you think will be their progress? So as we proceed, just try to recall from the last class that we said the rate is a rate or work speed or pace is the amount of work you can do per time, the work, how soon you can finish a task. Okay, remember that. Now let us define these terms. That is, if W, capital W, is complete work volume, this W is the complete work volume, and T is time to taking to complete all W work. So that is what we're using now. What about if we say something like small W is the amount of work done after T days, after small T days. We said W represent the total work. Now the total work is usually depends on how you want to specify it. For example, if I'm running a loading company, yeah, I say, okay, I discovered that Mr. Hay, I want him to load 10,000 bags of cement, and it's going to take him 3 days. I tried Mr. B and I saw that it took him 2 days. So 10 bags of cement is the complete work. I'm just dealing with the complete work, the total job I want to do in that respect. So I'm not breaking it down. Now, what if we're breaking it down? Say, okay, let's say half of the work. So I want to define a small w to represent that, to represent what you can do after T days. Not now. We're not now dealing with the complete work. So okay, my complete work, there are 10,000 bags in a shop. I want to load them onto a truck. That's my complete work. Now, after, maybe it takes people 10 days to do that, or let's say it takes people 2 days to 20 10 hours to do that. So what about after 5 hours? That is small t. How much will I have completed? What's W would have completed? Okay, let's proceed. We record that we also said earlier that Harry is the rate of the first person. Rate of A is the inverse of time. You would just take W over work, W over TA. RB is the same thing, the full work W over CB. Don't forget in the last example we saw W is going to cross out by the time you will need to. So let's just leave it like that. The combined rate will be 1 over TA plus 1 over TB. Okay, so given your time T and work speed R, now you have to find in this question. In questions of this type, we're giving your time elapsed, that is after 2 days, after 5 days, after 10 hours, etc. Now you're giving your work speed. You're giving the work speed for personnel A, the work speed for personnel B, personnel C, D, and so on. So you're just going to find the combined rate since they're working together, and then what quantity of work will they have completed. Now let's take an example now. Okay, so here, this is just what we need to do. So the work is rate times time. From the formula here, work becomes rate times time. And so the small w is rate times small time. Okay, it's just like saying there's a machine that can produce 5,000 bottles per hour. That's the rate. Now after 2 hours, how many would I produce? So it's just a simple multiplication. Now let's go on. So don't forget our R is 1 over TA plus 1 over TB, 1 over plus 1 over TC. So it's now times time. Now there's a question here. Sorry, take this to early. This is a question. It says Mr. Paul can normally complete a task in 18 days, and the other one is boss Sandra can finish the same in 7 days. Working together, what fraction or decimal of work would have been completed after 2 days? So your time now is 2 days. The work rate is 18 and 7 respectively. For look at the question again. You can go to the website again. The website is sublots.blogspot.com. We see this is an exercise, quantitative reasoning, work and time problems, volume 1 part 2. So let me hide the workings for now. Just click that button, you hide the workings. Okay, so 18 days, 7 days, working together, what fraction of work we are completed after 2 days? Just take it this way. So solve these, and what do you have? You get 0.396 is the answer. So 0.396 is what we have. Is that the question we're answering? Yeah, 0.396. That's approximately 0.4. So we can check our answer here. Yeah, and that's it. Yeah. So what if it's in fractions? Just say what's the nearest to 0.396 expressed in fractions? That's something like 4 over 10. That's it, which is 2 over 5. So another question may say percentage. Percentage, that's 39.6%, 40%. Some other question may say what percentage will be left that is yet, or what is the percentage incompletion? It's all the same. Percentage left will be 60%, 100 minus 40, and this is the fraction that's left is 1 minus this, or fraction that's left to be 3 over 5. 1 minus 2 over 5, that's 3 over 5. So that's how you just handle it. So in summary, this is how you, whenever you see a question that's looking for percentage progress, it's this completion degree is sum of time inverse time times time elapsed. What does that mean? Just take the time and keep calculating the inverse, and sum it together. If I were you, I'll just pick my calculator. I see a question like this. I know this is what it is. I press 1 divided by 18 plus 1 divided by 17. If they mention another worker, maybe another person will take 3 days. 1 divided by 3, sum everything, then multiply by 2. You get your answer straight. It's that simple. You need to be fast when you're handling questions like that. I think we should just take probably we should take one more example. Let's see. Okay, let's see. Is there any? Let's see. Let's look for a similar question. Okay, question 9 is a similar question. Joseph can do a work in 15 hours, and Margaret in 18 hours. What would be their completion percentage if they have to work for 8 hours? So 1 over 15 plus 1 over 18 times 8. That's all you need to do. Okay. Let me use a calculator here. Hey, don't forget is we are 15 and 18. 15, 18, 8. So just punch it. 15 and 18, 18 and 15. So the inverse. This is the inverse. Now sum 0.1222. Now multiply by 2. 0.244. So let's see 0.244. Oh, sorry. After 8 hours. Time is 8 hours. So that's 0.977. 0.98 is the answer. So percentage would be 98 multiplied by 100. So 98% is the time. Let's check the answer here. So you see, it's 7.8 is the answer. So just make sure you get it and make sure the question is similar. Don't go and apply it for the wrong questions. And also try to understand when you try to twist it. Maybe they say the percentage that is left to be completed. How much is left to complete? How much do you need to finish up? It's all the same. Just try and get the understand the